Hello. In this video we're going to show how the displacement, velocity and acceleration of various moving objects change with time. But first of all, you can see that I'm standing at the 3-metre mark. This is my displacement from the left-hand side of the screen. Displacement is a vector quantity since it has both size, that's 3 metres, and direction from the left. It's usually represented by the letter S. Above me is a displacement time graph of my position from the left-hand side of the screen. So long as I stand here, the graph is simply a straight line, staying at 3 metres as time goes on. But if I suddenly disappear and reappear at a displacement of 1 metre, the graph changes, as you can see. If I walk across the screen at a constant speed, my displacement from the left-hand side will increase at a constant rate. The rate of change of displacement is known as velocity, and it's also a vector quantity, usually represented by the letter V. You'll see from the graphs how my displacement and velocity change with time as I walk across the screen. At the start of the race, the sprinter is stationary. Her velocity is 0. But she soon reaches a maximum velocity. When something's velocity changes, it is said to be accelerating. Acceleration can be defined as the rate of change of velocity. Here is a simple device to detect acceleration. It's made from 2 glass plates with some coloured liquid in between. If the accelerometer is at rest or moving with constant velocity, then the liquid level is horizontal. But if its velocity is changing, then the surface tilts. The greater the acceleration, the greater the angle of tilt. Here, the accelerometer has been calibrated. It will measure acceleration in meters per second per second. Now you'll see the accelerometer being used on an air track vehicle. The vehicle will be pulled along the track by a weight at the other end. The weight will pull the vehicle along with a constant force. If you look at the liquid surface, you will see that it stays at a constant angle until the vehicle has stopped. Here again, the accelerometer shows that the vehicle has had a constant acceleration while it was pulled with a constant force. The graph shows how its acceleration changes with time. Its velocity increases at a constant rate, and the displacement time graph is a curve as shown. Now let us look at how the acceleration, velocity and displacement vary with time for a moving car. The accelerometer has been mounted on the extreme right of the dashboard. It works when it's set along the direction of the acceleration, so a mirror has been used to produce an image of the accelerometer next to the speedometer. We're going to see the car moving past some posts which are about 3 meters apart. You'll be able to see how the displacement, velocity and acceleration of the car change as it moves. You'll see this again, and the times at which the car reaches the posts will appear on the screen. You can use this information to sketch graphs of the car's motion. Now the car will accelerate from rest. Now the times will appear as before. You can tell that the speed of the car increases because the time intervals are getting shorter. Perhaps you can work out what's happening here.